Hi everyone, I'm Zairah. I'm the Senior Data Scientist at U.com. I'm humbled, at the same time really excited to be here, thanks to the organizers of the conference and everyone who is joining today. So before I start with my presentation, just a quick intro about U.com if you guys are not aware. It's a search engine startup. Our co-founders are two of the most leading researchers in NLP, Richard Socher and Brian McCann. And U.com started in 2022 November, and we provide search engine capabilities to our users, which are able to provide factually correct answers to users. As you can see, we provide citations if you have any queries, and we also have summarization capabilities. So if you're, as a user, you're searching for something in a web page or across PDFs or across different sources, you can just hit the summarize option and you can get summarized answers for your queries. And we also support multimodal AI features like image generation, and all of these clubbed together enable our users to become more productive and get the answers for the questions that they're looking for. So a lot of, to support all of this all of these kinds of features, it requires a lot of engineering and a lot of different pieces being able to, work together. So I'll speak about some of that in the talk today. So obviously, over the last few months, all of us, I'm sure, have seen this kind of a news headline where people are like, oh, generative AI is going to take over our jobs, or it's going to increase the potential in our economy. It may have a huge impact on healthcare. There are concerns around its privacy, and so all things are going on. So, but one thing that I think is pretty clear is that it is getting integrated into our workflows, and we have to come together as a community to understand the different pieces and deploy the AI models more responsibly. So this is just one visual that I like to think about when I think about a lot of things in AI, and I'll try to explain what that means. So there is a physicist and a mathematician named Freeman Dyson who basically wrote these lines in his essay, Birds and Frogs, where he says that birds fly high in the air and survey broad vistas of mathematics out to the far horizon. They delight in concepts that unify our thinking. And then there are frogs who live in the mud below and see only the flowers that grow nearby, and they delight in the details and particularities of those objects. So you might wonder why I'm talking about birds and frogs in a talk for AI, but I like to think about these as an analogy for large language models and fine-tuned models. So large language models are something that I call birds, and then frogs are something that are expertise in certain domain, and they have a narrow vision. And it's a good analogy that I like to keep in my mind just when I'm building technology. So large language models, as I said, are generalists. They are trained on massive amounts of data, and they have a bird's eye view. And then fine-tuned models are specialized on certain specific tasks, and they have a little bit of a narrower view. So these concepts are kind of important when we are building applications for that use these pre-trained large language models. And this is how I like to think about the production use cases that I have seen in my experience, broken down into 3 different tiers. The first tier is where you, if your application that you're developing, maybe you're working in a hackathon, or maybe the application that you have is simple enough that it only requires you to make a few calls to the external APIs that support, calling the pre-trained models. So those are tier 1, where it's relatively easy to productionize them, and you don't have to take care of a lot of different pieces moving around. in tier 1. Then there is tier 2, which I think where most of the research and a lot of the companies are focusing today, where you take the pre-trained models, but you also add something to them, for example, recent information, or you can have certain specific sources that you can use, or you can take the output of the pre-trained large language model and put it inside your own application and have it be used in your downstream applications. So obviously, when you think about that kind of infrastructure, you will have to think about a lot of engineering details to think about cost and latency of all these pieces talking to each other and having also like an end-to-end latency and all those things. So that tier will come with its own problems, which are not what you typically will see in tier 1. And then there is tier 3, which is also something that I see a lot, like a lot of companies focus on, which is like building co-pilots or having agentic features in their products. And there's like a lot more automation compared to tier 1. But tier 3 is like, oh, we let the LLM or the pre-trained models handle a lot of or most of the things, where they can even maybe take actions for us, which is what happens in co-pilot and agent-based products. Yeah, I mean, in every tier, wherever you fall, you will have to go through its own challenges and the difficulties that come with that. So now that we know about all these different tiers, how can you basically customize pre-trained models? There are a few techniques that we can use for that. Like, you can either do prompt engineering or fine-tuning, or what we call is prompt tuning. So I'll walk over all 3 of them briefly, and we can and discuss some of the details there. So prompt engineering is something that is a lot more intuitive. So let's say you are interacting with some kind of a pre-trained model, and you want to write, you want it to help you write an essay, or you're looking for some kind of an information. So I would encourage everyone to think that prompt is not just a question that you can ask. You can get more details. For example, in this example here, write an essay on climate change. If this is the only thing that you put in the prompt, then the model is most likely going to come back with a response which is a little bit more generic. But maybe you want more from your large language model. You want to extract more information. So in cases, you can get more. In those cases, you can get more creative with your prompts and give it more details. So you can be more specific and say, help me write an essay about climate change, but also include these topics and make sure that it covers public policy and a few other things that maybe you care about. And the more specific you are with your prompt, the better response that you're going to get from the model. So in this case, the output will be a lot more tailored to your needs instead of being something that's very generic. The other example that I would use is something that we call zero-shot learning. So let's say you're using this, you're using a large language model to maybe do some kind of a prediction in your product. So you can say, classify the text into neutral, negative, or positive, whatever your task is, and then you give it the text, which is like, I think the movie is amazing, and then it's going to output the sentiment as positive. So this is zero-shot learning, where you don't give the model any examples, and whatever examples it's been pre-trained on, it's just going to use that information to give you the response. The other way of improving the quality of your answer is to use what is called a few-shot learning. So few-shot learning is when, in addition to the task and the final text, you give it some examples, prior examples, just a few are enough. In this case, I tell the model that this is positive and the other one is negative. And that way, if it hasn't seen this kind of data before in its pre-training, it's gonna take this as an input and give you output for your particular output format that you're looking for. Also, there are like use cases when you're building applications where, let's say you want the prompt, you want the model to specifically output like positive, negative, and neutral, like those strings. So that is also one good use case where you want to do some few shot learning, and then it's gonna give you the response based on what you give in the input. Next comes fine-tuning. So I wouldn't say that this is like a comprehensive view of the types of fine-tuning, but these are like some that I'll discuss today. So in fine-tuning, we can think about first case, which is called multitask learning. This is the case which involves training the models to perform multiple tasks simultaneously. Now, in the previous example, you saw that I was asking the model to do like sentiment analysis, positive or negative. In multitask learning, you can fine-tune the model such that it's able to perform multiple tasks. So sentiment analysis and maybe also like intent classification or something else. So it's going to be oriented towards being able to multitask. The other is few shot, which I also gave an example before, where you give certain specific domain-specific examples to the pre-trained model, and then based on that, it's going to give you more tailored answers. And then there is domain-specific fine-tuning, which for example, you take a large language model which has like a bird's view, like I described earlier, and now you want to tailor it to, like, let's say, finance data. And so you'll do that domain-specific fine-tuning, provide it with the corpus of finance data, and then it's going to learn the vocabulary of that specific domain, become like a domain expert, and that falls in the category of domain-specific fine-tuning. And the final one is prompt-based fine-tuning, which I'll go over in a bit. The reason why I've put it in a different color is because there is a difference between prompt-based fine-tuning and all of the other all the other fine-tunings, and that is that in other fine-tuning types, you require retraining the model, and that is something that you want to keep in mind, because retraining these models is costly. It's not easy to get data to retrain them, and so you have to think about all those decisions. Whereas prompt-based tuning is something that enables you to tailor the pre-trained model towards your specific tasks without needing to retrain the foundation model. So in prompt tuning, the model weights are basically frozen, and the parameters of the soft prompt are used through are updated through optimization. And yeah, it's cost effective. You don't have to like worry about retraining the foundation model from scratch or think about providing data set for that. So all these things that I've said so far, I'd like to summarize it using this diagram. So let's say you have this pre-trained model that you're using. Now, if you glance at this picture, it gives a good picture of like what's the difference between fine-tuning, prompt engineering, and prompt tuning, which are some of the ways that you can interact with pre-trained models. So in fine-tuning, what you do is there is like an input. For example, I was earlier asking, whether this is like a positive sentiment or a negative sentiment. But in addition to the input that maybe the user of your product is giving to the model through the interface that you've built, you also give it some additional training data. So maybe you have trained the retrained the model using some kind of specific sentiment data set, and so it's able to give better answers. Then in prompt engineering, you can do few shot learning and the other examples that I showed you. So in addition to the input, you have something else engineered inside the prompt itself. And then there is prompt tuning, which I went over before. So this is like an overview of the three types, three ways that you can interact with pre-trained models. So in summary, I would say that if you're thinking about some good principles for prompting, then be very clear and concise in terms of what you want to get out of the pre-trained model. If you wanted to do like, I tell you the sentiment of some data set, or if you're trying to do train it for something specific for like medical use cases and things like that, then be very specific about those instructions. Also, sometimes it helps to take your time to think before you answer kind of an additional string in your prompt. And there is some research out there that says that it has proven to get return some good results with that. And then we discussed about the zero-shot and few-shot learning. You can also ask it to generate certain structured data, like if you have some kind of a use case where you want it to output a JSON as an output, or a CSV file as an output. You can say that, this is what I want to do what I want from you, and give me the output in a CSV. These are some of the good principles that you can follow. And then lastly, the big question comes where we went over fine-tuning, prompt tuning, and prompt engineering. But then how do you kind of decide between when do you need prompt engineering, fine-tuning, or prompt tuning? So this is something that really, really depends on your use case specifically. So let's say you're training some kind of a QA system for software platform. And then there are a few questions that you want to be asking at that time, which is like, the specific use case that you have, do you think that the LLM would have been pre-trained on that data set? So if your use case, whatever you're trying to build your product for, if the data set for that is mostly public, then it's a good assumption that these foundation models have already seen that data. And so maybe you don't need fine-tuning in that case, and that you can just use them off the shelf and save a bunch of cost there. The other question that you might ask is, does your organization have the ML infrastructure to be able to do fine-tuning? Because fine-tuning is not something that's super simple. It requires certain engineers who have the expertise, or it also requires infrastructure for that. So that's a good question to ask before you go ahead and do fine-tuning. And then also how novel your task is. So today, I don't think we have this kind of a system that we can trust, which would give us questions for medical needs, right? Like if you go to a chatbot and ask something like, I have these symptoms, what medicine can I take? I don't think we have that technology yet where we can trust some kind of a system. So if the novelty of your product is something that's has those kinds of risk factors, then maybe using the off-the-shelf models is something that you should restrain from and think about how to invest in more fine-tuning and training. So in summary, we saw the world of pre-trained large language models through the eyes of birds and frogs. And the idea that I like to think is that it's all about the interplay between the large language models and those fine-tuned models that you need for your specific tasks. And that's it. Thank you so much. Here you can follow me on Twitter or LinkedIn, and I'm happy to take more questions in the Q&A section at 3 p.m. I believe as well. Thank you.